Welcome to Remote Trigonometry. Trigonometry is the mathematics that's behind the light that we see, the sounds that we hear, the structures that we build, the molecules that fit together, and how our world turns. A worthwhile endeavor. In this episode of Remote Trigonometry, we're going to be looking at how there are always going to be two solutions when sine or cosine is set equal to a number. That is, unless you're solving for the number that gives you the maximum or top of the wave or bottom of the wave. As you can see, if you're at the top of the wave, there's only going to be one solution per wave, or if you're at the very bottom, there's only one solution per wave. But if you're not at the top or the bottom, there's always going to be two places where you slice through the wave at any certain value. Now, if you're working with cosine, remember cosine's the x coordinate as you rotate around the unit circle. The x stays the same whether I rotate positive or whether I rotate negative. So notice the x stays the same. And so cosine of theta is equal to cosine of negative theta. It also turns out that if you looked at this location as almost a full rotation, so 2 pi is a full rotation, so 2 pi, but then you're stopping short this size angle, then that angle would be 2 pi minus theta. And so cosine of theta gives you the same value as cosine of negative theta, gives you the same value of cosine of 2 pi minus theta. We can look at that on the calculator. If I put in, say, cosine of 0.3, I get that value. If I take cosine of negative 0.3, I get the same value. If I do cosine of 2 pi minus 0.3, notice they're all the same value. And that's true whether the angle is positive or negative. Now for sine, it's a little more complicated. Sine, again, is the y coordinate as you rotate around the unit circle. And if I rotate a certain angle, this y value matches up with the y value over here in quadrant 2. And so this angle right here is a half circle minus whatever this angle was, and that angle's the same size as theta. So sine of theta will always be equal to sine of pi minus theta. Now, if your angle is negative, your calculator is going to give you the negative angle as the answer, and you're going to have to reason out the second answer. And if the angle's negative, then you're going to use pi plus beta. So notice if I rotate one whole half, like a half circle, and then I go a little bit further, this angle is the same size as that angle. So it's pi plus this angle of beta. So looking at that on the calculator, for an example, if I take sine of 0.3, I get this value, 0.2955. If I take sine of pi minus 0.3, notice I get the same value. If I take sine of negative 0.3, I get negative 0.2955. If I take sine of pi plus 0.3, okay, notice I'm not adding negative 0.3, I'm adding 0.3, I get the same value, negative 0.2955. So if the angle's negative, it's pi plus the magnitude or the size of the angle. If the angle's positive, then you're going to use pi minus the angle to get the second solution. So looking back at the graph here, notice for cosine, negative theta is giving you the same solution as theta, is giving you the same solution as 2 pi minus theta. And then this solution is kind of matching up with that one. It's one wavelength away from this solution. You're always going to get repeated solutions if you just keep adding the wavelength. And then if you're working with sine, here's a theta, you're going to get the same solution at pi minus theta. Unless your angle's negative, or your value's negative, so here's negative beta the other solution that's going to match up is pi plus beta.